Good afternoon. Welcome to the Embedded Executive Podcast. My name is Rich Nass. I am with Embedded Computing Design. My guest this week is Sean Dougherty. He is the Vice President at Everspin. How you doing, Sean?
I'm doing well, Rich. How are you?
I'm doing great. So, to prep the audience, we ran into each other last week. Boy, I don't even remember when it was.
Week before, probably. Yeah.
Yeah, at Embedded World in Nuremberg. And um, there were a couple of themes that everybody wanted to talk about. One was artificial intelligence, one was CRA, but the other one that people wanted to talk about, but nobody wanted to talk about, was the memory crisis, the memory crunch, whatever you want to call it. And you guys at Everspin are sort of in the thick of this. So before we talk about that, let me just give you a second or two to talk about Everspin so that the audience understands where you're coming from. What do you guys do?
Yeah, so fundamentally, we make non-volatile memory, but we make very, very high performative non-volatile memory. Much higher write bandwidth, read bandwidth, much higher endurance, and much higher data retention.
Okay, well, that was easy. Thank you. So first, is there a memory crisis?
Absolutely. Uh, I think you felt it at the show, and the memory crisis is driven by the AI boom and everybody and anybody feeding the insatiable demand of the AI deployments that are going on, which are real and are being fully utilized as they get deployed. So everybody that's in the market that makes memories is trying to feed that. Primarily, it's not really in my background in the MRAM customers, but if you look at the demand for HBM, for DRAM, for NAND, all of that is pushing capacity decisions for the NOR makers to feed into that space. So if they have capacity and are able to shift into those players, they are. And over the last quarters and years, you've seen people in the non-volatile in the NOR space decommitting customer supply and prices going through the roof. And Everspin and MRAM has been extremely stable on capacity and extremely stable on price and lead time.
But we've seen memory intensive applications before. Why is this one different?
Well, I think we've seen memory intensive applications before, and I think we've seen the industry for 20 plus years commoditizing memory in all shapes and forms, forcing players off the playing field because it became commercially non-viable. And now it's literally getting to the point where everybody points to memory in the memory wall as being the performance bottleneck that is stopping advancement or limiting the upside of advancement. And you see this around the NVIDIA architectures, the AMD architectures, the Intel architectures, that they need that HBM and that DRAM. And the amount of that just continues to skyrocket as AI matures, the amount of memory required to feed it, and the bandwidth and the networking of moving the memory around to get to the right compute at the right time has created this challenge.
So being the skeptic that I'm supposed to be, is this real or is it fabricated? Are the memory guys producing as much as they can, or are they holding back to artificially inflate the prices?
It's real. No, it's flat out real. And again, the market has, pushed out players off of the field. For years, it was everybody jump on, the DRAM architecture that the PC and the server guys are using because you would benefit from the commercial price drop of that technology. Now everybody gets on that same technology at the same time. And for years, we've seen the transition from DDR3 to DDR4, from DDR4 to DDR5 as the prices move, and everyone moved with it. So everybody's on the same technology, and all of these deployments are being fully saturated. So I don't, unlike the networking build out dark fiber back in the day where you had all this capacity that wasn't being utilized, I do not believe there is any compute that is being deployed that is, as soon as it's deployed, it's not fully being utilized. So I don't
Huh?
believe that there's all these NVIDIA architects sitting out there that aren't being fired up and aren't being used if they have the ability. So I believe it's real.
And I think you said this, but I want to be very clear about it. Are we putting the guys who are willing to pay the higher prices, aka the data centers, at the front of the line?
I mean, I'm not in those rooms, but I would be shocked if you're not, right? I mean, I think that's we've been through supply challenges a dozen times, and every time the folks that are paying the most tend to move to the top and in front of the line. I don't think that's being done necessarily, with a lack of integrity. But at the end of the day, if you put yourself in any of these memory vendors' positions, they've spent 20 plus years being commoditized. And now they're at the table with what the architectures, the systems, and the customers need, and they're able to command, the margin and the profit they need to invest, Rich. And this is the key point, right? At the same time, if you don't want this to exist for 20 years, then these guys need to invest, put more holes in the ground, build more capacity, and not just build capacity, but innovate on architectures. That, to be quite honest, there hasn't been the level of investment in memory architectures the way there's been investment in funding in other areas of tech. So, if you want the memory guys to produce more memory, they're going to have to make enough money to justify that investment in capacity and R&D.
But that's a solution that's many years down the road.
Correct.
What's the solution for this year and next year?
So, to be quite honest, I believe there's not a real short term. Unlike the previous supply challenge where it came on like overnight and people were lines down. I think right now there's some supply out there and people are moving. I think the challenge people are getting is they're not getting supply agreements and supply commitments that make them feel good about all of 26 and 27. So it's not clear to me yet that the acute problem on the near term. It is there on the DRAM stuff, and I think that's happening and people are chasing, but I don't think that's happening yet in the non-volatiles. But to be quite honest, I don't know if there is a near-term solution other than what is needed to level the playing field to make sure that the deployments happen. As we learned the lesson last time, you can feed one segment of the industry, give all the supply to the server guy. But if the server guy can't power the rack, can't cool the data center, can't do all this stuff. All of these solutions, industrial solutions that power and manage the data center, all require a lot of the same technology. So I think you'll see these allocations. Then you'll see another phase of reallocation when they can't deploy the solution because the underlying infrastructure can't deploy. You'll see a reallocation of some of this stuff to make sure that you can maximize again what you can deploy with a fixed capacity in a given window.
It seemed like the last time we had this crunch, it was the automotive space that got hit the hardest. What space do you see taking the biggest hit this time around?
I don't know, to be honest with you. I think it's too early to tell. My guess is it would probably be the commercial commoditized space will probably get hit the most. Um, you saw end of last year where Samsung was having an internal battle on whether or not phones got the parts or those parts went elsewhere. So I think the widgets and the toys may get the biggest impact and be forced to do the most change. But I think anything that plays in AI will be less impacted, and that's across industrial and automotive. And
Mm-hmm.
if you were at the show, right? AI is in everything, and I think those solutions that are able to justify the ROI on the investment are probably going to do better than ones that are struggling there.
Do you think it could be geography based, where people sort of, I won't say help their friends out, but help their friends out?
Um, I think those things always play, right? I think the lessons of the last crisis that's still fresh in minds is that certain geographies and governments and folks have the ability to flip some levers to get what they need, and those will always those cards will always get played where they need to. And again, your ecosystem will always kind of think of the survivor game, right? Where people get together and we saw that last time where big guys were swapping capacity on, hey, I got some capacity on this node, but I need it over here. You need it on this node. So it's amazing where all of a sudden allegiances and allies all of a sudden get formed in a crisis. So I think you'll see some of that stuff play out if and when it becomes acute.
So let's have full disclosure. Is this a good thing for Everspin?
Yes, I think because number one, we have supply, we have upside capacity, we have a current shipping solution that is pin compatible and protocol compatible with many of the NOR parts that are on the market. So if customers have challenges, we're able to step in there and offer them an alternative. I promise you, I won't commoditize myself or my product because I believe in the value, and I think my customers will believe in the value once they see it. But we will work with customers to help solve problems. And over the last month, we've had many conversations where, number one, customers weren't aware of the pin compatibility and how easy it would be to modify their manufacturing and driver to get us qualled on their system as a second or a third source just to provide insurance. So we're having a lot of those conversations. And I think another memory vendor that's able to provide a capacity and solve problems is always good. Now, some of them may not be long-term customers, but I believe they'll learn our technology. I believe I will earn their trust in their business and an opportunity to come back and talk about what we're bringing to the table with respect to our roadmap and innovation.
That sounds great. You need memory, you call Sean. He's got it, right?
I like the way you talk, Rich.
Very good. Well, I really appreciate you taking the time, Sean, but also being honest and forthcoming because this is a real problem that we need to deal with.
Agreed. I'm looking forward to engaging with customers and partners as they see these challenges arise.
Very good. That's Sean Dowdy. He is a vice president with Everspin, and I am Rich Nass with Embedded Computing Design.